Here he is once again. Welcome back, Doctor, and let's see who's on the lines. Let's go to Orlando, Florida. You're on the air with my guest. Hi.
Hi, my name is Dan. I wanted to ask two questions if possible.
Sure.
First of all, does your guest believe that there's any truth to the charge or the claim that fracking contributes to triggering earthquakes? And could he comment on the case in Italy a few years ago where I believe several seismologists were actually convicted, I believe, of manslaughter because they had failed to predict an earthquake that occurred? I believe their charge was reduced, but I wonder if he could comment on that.
Actually, I heard about that, and I meant to ask about fracking, so thank you for both questions. Doctor?
Oh, yes. Fracking, without a doubt, can cause earthquakes. It doesn't always. However, there's a big unknown question here, and that is whether fracking could actually trigger a destructive earthquake. There's a lot of earthquakes going on in Oklahoma right now, much more than have occurred in history.
Right.
And they are, well, actually, it's not actually the fracking that's going on. It's the reinjection of wastewater that's going on. And that is producing these earthquakes.
But that is a product of fracking, right?
For fracking is actually putting down various types of chemicals at high pressure to actually break the rock. Mostly what's going on in places such as Oklahoma is putting down wastewater, and you put it down under pressure. However, if there's not enough stress in the crust already, it's not going to produce earthquakes. And there are many places where they're fracking and it's not creating earthquakes. So it doesn't always happen, but it can.
I am familiar with the ones you talk about in Oklahoma that have just occurred. In fact, there's something odd going on with them, Doctor, and it is that people are hearing this gigantic bang just before the earthquake. Have you heard of that?
Yes, that is one of the great unknowns in earthquake science, earthquake sounds. And people still scratch their heads, and there's so many credible people have heard earthquake sounds. The problem is the sound travels slower in air than the earthquake travels in the ground.
Okay.
And so what you should do is feel the ground shake and then hear the rumble. But that's not what happens. You hear the rumbling, and then the ground shakes. And people have been trying to figure out why this thing of earthquake sounds. So it's one of the things we don't understand in earthquake science.
Gotcha. All right, let's go to...
Now, what happened in Italy?
Is there?
There's plenty of guilt to go around here.
That's right.
In this part of Italy, there were earthquakes going on. Government officials, I lived in Italy for 3 years. I knew some of these people. They went to the community and said that there was no chance of a damaging earthquake. What they should have said is that there is no increased chance of a damaging earthquake.
I see.
And because they said there's no chance of an earthquake, one happened, it did a lot of damage, fatalities. There's a different system of law in Italy, and they were charged and convicted, and most of them, except for one, actually was serving time in jail. It comes back to, as a scientist, how do I communicate things which are a concern with the public?
Or even do I communicate under those circumstances? That's
right. However, you have to tell them. You can't if you try to hold a secret, the better the secret is, the more likely someone's going to hear it. That's why for like Mount Hood and Mount Rainier, I cannot tell you that those things aren't going to erupt next week. It's not very likely. We don't have any indication, but right now there's very little risk of it.
Mm-hmm. Well, I guess it's just not good in science in these areas to make definitive statements one way or the other. Get you in trouble, I guess, huh?
Well, it depends if it's a test of knowledge here. And it's also a test of the size of a scientist's ego. To be able to stand up and have a lot of attention and make these pronouncements, I mean, the ego goes way up.
Well, for a while.
But if you sit up there and you mumble around and you give all these qualifications that maybe this, maybe that, the public will say, what's the use?
Right.
So you have to learn to actually communicate things.
All right. Here's somebody from one of those areas, Portland, Oregon. Hello, you're on the air. Hello, Portland. Portland, Oregon.
Okay, can you hear me?
I hear you, sort of.
I'm sorry.
You don't have a really good connection, to be honest.
I'm sorry. Sorry about that.
Okay, better now. Go.
My question was, you were talking about multiverses and black holes, and I was just wondering what your take was on the depiction of a black hole and multiverses in the movie Interstellar.
Oh, yes.
I loved Interstellar except for the first 40 minutes, and I don't understand why the first 40 minutes were there. That was so slow. Interstellar got the time dilation exactly right. That is, going close to a black hole, you don't age as fast. And I thought the way that they did it was brilliant. What they did with the physics of the black hole was more of a Hollywood take than what happens in science and what we know about it, or the physics of a black hole. I don't recall. I saw the movie. Did they actually pass the event horizon?
Yeah, he goes into the black hole, and it's a little confusing. But he basically he exists in a tesseract, and he can go to any point in time in his daughter's life.
That's right.
Throughout,
if I had been an advisor on that film, I would have said, okay, let's not use a black hole. Let's use a wormhole. A wormhole has that type of physics. However, nobody has proof of the existence of a wormhole yet. That's one of the very curious things in the history of physics. Einstein developed the general theory of relativity in 1915. Less than a year later, a German scientist called Schwarzschild found solutions. Two. One was a black hole, one is a wormhole. And now we have lots of evidence for the existence of black holes, but we still don't know if wormholes are a reality.
You know, the end of that movie confused me a little bit, too. Did you watch?
They actually use a wormhole as a plot point for them to travel across the universe.
Mm-hmm.
Right, and that's what happens with a wormhole if they exist. Also, I had no idea, what was the thing with the fight with Matt Damon? That didn't move the narrative along at all.
You should be an advisor on a movie. Would you like to do that?
Well, I would certainly entertain it. I'm actually an introverted person who doesn't like to be in crowds. That's part of why I live out in the middle of the Pacific.
Well, Hawaii is, I don't know if you'd say it's crowded, but fairly so. And here you are on a radio show, thousands of people. You're doing okay.
On this island, it's all rural.
Well, that's true. That's true. All right. Thank you very much, caller. And on Skype, I believe it's Nick. Hello, Nick.
Hello, Art.
Hi.
Hi, and hello, Dr. Dvorak.
Yes.
Yeah, I had one comment to add just to the fracking discussion real quick, and I also had a question that has to do with a different area of your expertise. The other caller from Orlando brought up fracking and its effect on earthquakes. I live in Dallas, Texas, and I've lived here for 20 years, never felt a single earthquake until the last year. And I've literally have felt over 30 earthquakes in the last year.
Wow.
It's pretty weird. It's big topic here, mostly out of the Irving area, but it's pretty scary. I guess I just wanted to kind of tell you that, and I think it's really frightening because they've been 3.5s, 3.3 so far. But I mean, is there a possibility of fracking causing something bigger? 6? Because I don't think anything's built for that here.
That's part of the ignorance. We know that fracking can produce earthquakes that are 3s and 4s. Whether they can actually produce 6s and 7s, we simply don't know.
But, Doctor, earlier you did say there could be a sort of a rolling stone down the hill effect. So if you produced a little one with fracking that could turn into a big one, that might happen.
That might happen. And that's why the research in trying to figure out what triggers a large earthquake is so critical. And the ignorance is very high on this question.
Well, it's just a little bit scary. My brother was visiting in town recently, and we were talking about the earthquakes, and it got to the point where there was an earthquake every 2 hours, and it got to the point where I was able to say, you know what, I think there's going to be an earthquake at 10 p.m. tonight, and I bet I'll be right within 10 minutes. And at about 10:15, there was an earthquake.
Well,
So,
I'm curious.
Very unusual.
What are the officials in the state of Texas telling you?
No big deal. We're talking about it, I guess, in the city council meetings. It's not a. I don't know. I guess I haven't heard the official word from them, but it seems to be downplayed a bit.
There must be a state geologist who has to issue an actual statement.
I guess, yeah, I haven't looked into that, but it's definitely interesting. I had one other question. Not exactly related to earthquakes, but it does have to do with something I know is in your area of expertise, which has to do with just other life in our solar system. I'd love to get your just quick thoughts on the possibility of life on Europa or Titan, and if you think that there's any significance to those claims.
I have to give you the non-scientific answer, okay? The one that is the passion in me. Mm-hmm. And that is microbial life is probably all over the solar system. Because we know that microbes, the deepest drill holes that have ever been put into the earth, they find microbes. You find them in those hot mud pots at Yellowstone. You find them in the ice in Antarctica. And the reason that they're probably spread all over the solar system is because a large impact will throw rocks out that will land on another planet or moon. And there certainly has been plenty of opportunity. But that's not a scientific answer. That's just one out of passion.
Okay.
Thank you. Thank you very much. Great show tonight.
Right.
Have a good night.
Thank you, caller, and take care. Hello there on the phone. You're on the air.
Yeah, the doctor probably more or less answered my question about the possibility of eruptions of Mount Rainier. I was wondering what his thoughts were on the supervolcano in Yellowstone, and what his thoughts on the possibility of that erupting.
Right, we did talk about that earlier, but sure.
Sure, the possibility of an eruption of Yellowstone is non-zero. That is, it's extremely low, but it's not zero. It's erupted many times in the past. It is certainly going to erupt in the future. There is a very large body under it that's molten, and at some point part of that is going to come out of the ground. Whether it comes out tomorrow or whether it comes out hundreds of thousands of years from now, no one knows.
Mm-hmm.
Yeah, I was under the impression that it was like every 250,000 years or so.
Well, there's always this tendency to try to think that nature operates like a clock. People think about in earthquakes, volcanic eruptions, that this earthquake is overdue. We're finding that things sort of cluster in time, like earthquakes do. But that is still very much debated in science.
So thank you very much, Doctor, for the answer. And good luck in your new show. I'm really enjoying it.
Well, thank you. It's very enjoyable to do. We're going to take a real quick break here and get back with Dr. Dvorak. It is a new world. It really is in so many ways. Do you have the feeling, Doctor, that technology is quickening, accelerating?
I'm not sure. I'm also interested in history, and people have been saying this for decades, a century, of how fast things are changing. And so I'm not really sure about. about that. Things are changing in a different way, and that's what history is about. The world is not static.
No, it is not. But the technological advances are, to me, seem as they're really ripping.
In some aspects, they certainly are. But when somebody started installing a telegraph, that was a big step up. The steamboat was a big step up. So yeah, things do move along through history.
I'm thinking of my iPhone.
It's just sort of hard. We cannot choose the part of history we live in. So we're spectators to it. It's just really hard to figure out how people 100 years from now are going to look back on us and say, well, they were immoral in this way, or what they were going to go on.
Well, while we're on that subject, do you think that travel in time, forward, backward, any way at all, will ever be possible?
If wormholes exist, then time travel exists. And the question is whether wormholes exist and whether you're able to keep them open long enough to pass anything through, like yourself. All that is open. Right now, all the physics says no, 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 but all the physics also said no, no, no about black holes for a very long time.
They sure did.
My deepest passion in my life, ever since I was 4 years old, is mathematics. I've been so intrigued by mathematics. And the mathematics says wormholes exist. And many a night, when we do a long exposure at the telescope, I go outside, I look up at the stars, and I say, I wonder where all the wormholes are.
I wonder if you'd see them at all.
Well, that is a good question. Nobody has come up with what they would actually look like in terms of even if you had a picture of one.
Well, I saw Jodie Foster go through one.
Yeah, I like that movie a lot.
My favorite movie of all time, frankly, is Contact. I love Contact.
Yeah, he touched, and that movie was not about science. Carl Sagan even said, "This is about faith."
Yes.
What is faith in your life?
Yes.
And people said, "Really?" And they said, "Yeah, that's what I was writing about. I'm not writing about time travel or science. I'm trying to tell you about faith and what it does and the component it plays in your life."
Oh, you are so right. You are so right. That is what that movie was all about. Calgary, Alberta, you're on the air. Hello.
Hello. I've just got a couple of things. First of all, something about an earthquake. But first of all, I know some people don't believe in coincidences. But how about this one? The moon is just far enough away from the Earth that during a full eclipse, it blocks out the sun exactly.
Right.
Like, sir, it wouldn't be enough. Any further away, it wouldn't be enough.
And you're suggesting when you say that what?
It was put at that distance, maybe somehow.
By a creator.
Who knows?
Okay.
It's just a big coincidence to me. And just one other thing, it's something I've heard since I was a kid, that during an earthquake, or before an earthquake, like dogs or other animals know what's coming.
That's right.
I don't know. Is there any studies on that, or is that just a tale? Or?
Well, Doctor, how about that? I mean, animals certainly sense them before we do. Is that fair to say?
Not quite.
No?
If you're with a friend,
burst that bubble,
and one friend is standing, and okay, you're in a room and you're lying on the ground, and your friend is standing, you will feel the earthquake first.
Huh.
And I know many people have said this. You know, I was at home, I was lying on the couch, and I felt the earthquake, and my wife didn't in the kitchen until later.
Right.
What is happening here is that people have heard of the P and S waves go by. The S wave carries almost all the energy, but it's slower. Huh. And so if you're lying on the ground, you have a better contact with the ground, and you're feeling the P wave. And if you're standing, you're probably not. What you're feeling is the S wave, which comes later. And so that's probably what they're feeling. in terms of the animals, people who report this are very sincere, without a doubt. But as I mentioned before, it's not consistent.
You don't buy it.
Well, it's anecdotal. And so what they're reporting, is true. What they saw is true. The question is, because it's not consistent, that's not a scientific observation.
Yes, but sometimes
it has to be internally consistent.
Right, but sometimes what is anecdotal becomes definitive.
And that's excellent. A lot of science eventually is born out of things that are anecdotal. And it's a question of trying to figure these things out as to all this noise that comes down of all these stories. Which one is going to tell us more about the basic physics of earthquakes?
Okay, fair enough. Cameron?
So anybody with an anecdote, I certainly believe that they're telling me the truth. That's what they saw.
Right. All right, Cameron, you're on the air with Dr. Dvorak.
Oh, good evening, Art. Good evening, Doctor.
Well, good evening.
Yes. Before I get started, me and the guys would like to say you have some lovely birds in the background.
Yeah, well, those are actually frogs out there.
Really?
Yes.
Well, this should be entertaining.
And it's loud to me every night.
So you let me think they were birds this whole time.
When you mentioned that, the sun was going down, and I thought they were birds. And later on the show, as it got darker, I said, no, those are frogs. And usually I have a couple in the house. But I don't have any in the house tonight. Those are all outside.
Okay. Frogs. Caller?
So, anyway.
Good ear, caller.
Yeah, I was wondering about Cascadia subduction zone. I've read a couple of things recently, effects of that, and how that would basically drop the edge of the plate because it's a major convergence zone for a couple of plates. And they say, like, the tsunami would wipe out, clear back to, like, 5 in Seattle. What would somebody standing in, like, between Idaho and Washington, North Idaho and the border of Washington, what would somebody feel up there in the farm hills where it's rolling and the soil is like consistency of old alluvial silt and clay?
All right.
There.
Well, if you're at that distance, say the border of Idaho and Washington, what you'll feel is the shaking of the ground. It won't be very strong. In fact, it will be a rather slow shaking. Most of the energy of the very fast waves have already dissipated. And so it's mostly just the shaking. People will probably feel that earthquake as far as Montana, maybe the Dakotas, and probably down to Arizona.
That's a fair way. Doctor, hold tight. We're at a break point. We'll be right back. This is Midnight. I'm Art Bell.
For Dark Matter News, I'm Leo Ashcraft.
Oh, come on now.
All the sounds of Earth. We Earthlings listen to them all the time. A baby cries, a bus rolls by, the wind keens and rains fall. These sounds and many more are included on NASA's Golden Record, a compendium of sounds of our planet that traveled out into space with the twin Voyager 1 and 2 missions in 1977. The phonograph disc itself was 12 inches and made from copper-plated gold. Previously, the tracks on the album were available as individual clips, but NASA this week released them as an entire recording available to listen to on streaming music service SoundCloud. You can pretend you're an alien way out somewhere in the universe, encountering a Voyager spacecraft and listening to an audio introduction to what Earth was like in 1977. You'll hear crickets, footsteps, Morse code, laughter, fire, a barking dog, and an elephant. The sounds on the record were chosen by a committee headed up by famed astronomer astrophysicist Carl Sagan. As NASA notes, it was intended to communicate a story of our world to extraterrestrials. The Golden Record was created before the age of the Internet. Would a new Golden Record today skip the sounds of a horse and cart and instead include a cell phone ringing or the clicking of a computer keyboard? To listen to the entire Golden Record, visit darkmatternews.com. UFO watchers are in a tiz over the discovery of an ancient skeleton with an elongated skull that resembles an alien. The humanoid skeleton was unearthed from a site known as Russia's Stonehenge, and it's being heralded as proof that aliens visited Earth thousands of years ago. However, archaeologists don't share the same view as alien hunters, insisting that the skeleton belonged to a female from a tribe that used to bind the head to make it grow out of shape. Read the full article at artbell.com. Got news, tips, questions, comments, or suggestions? We'd love to hear from you. Visit us at darkmatternews.com. A mystery over a group picture. Everyone was having a good time until they noticed that they were being photobombed by a ghost. Nothing out of the ordinary seemed to be going on when the photos were taken. But when they took a closer look, that's when they said they noticed a shadowy figure peering out at them from the second-story window. Natasha Oliver and her friends were hanging out in her hometown of Wim in Shropshire, UK. Oliver told ABC News that she truly believes there is a ghost woman and her baby in that window. She and her friends freaked out after they saw the photo on her digital camera back in 2010, taken when they were hanging out on the front lawn of the unfinished home still being built at the time. Oliver said, "When we saw the ghostly figure, the boys climbed up the scaffolding to see what was up there, thinking maybe someone was watching, but there was nothing up there. There were no floorboards or anything." Though the photo was taken almost 5 years ago, Oliver said it recently got widespread attention after she commented on a Facebook post about a fake ghost picture. Though some on social media believe Oliver's photo could be photoshopped, she insisted it wasn't, and added she hopes to get in touch with professional photo analysts and paranormal experts to solve the mystery of the ghost in the window. The town of Wim, where the picture was taken, previously made headlines about reported paranormal activity in 1995 when a photographer claimed he captured an image of a little girl's ghost at the ruins of the town hall that was ravaged by a fire in 1677. Oliver concludes by saying, "I didn't believe in ghosts before, but I do now. Actually, I've converted." Fake or real? Take a look at the photos yourself and let us know what you think. darkmatternews.com.
Welcome back, Doctor.
Well, thank you.
Lots of people want to ask questions, so let's rage along and see what we find. Wherever you are, you're on the air. Hello.
This is Patrick in Richmond, Virginia, listening on WTWW shortwave at 5085 kilohertz.
That's the way to give a promo.
That is packing a walloping 100 kilowatt signal, and I think it's lighting up the ionosphere worldwide.
I'm sure.
So my question for your guest is, according to Einstein's famous equation equals mc squared, one has to realize that c squared is simply a constant of 90 quadrillion. So if you divide both sides of that equation by 90 quadrillion, you get energy divided by 90 quadrillion equals mass. It seems to me impossible that mass could hold all that energy without just vaporizing or dissolving or blowing apart. Could it be that this is a placeholder where some of that energy has to be transferred to a higher dimension in order for it to exist as stable gravitational producing mass?
Well, the equation E equals mc squared just tells you that mass and energy are the same thing. I think the question you're asking is whether part of that energy or mass could actually go into other dimensions.
Right.
That's actually a very good question to ask, because people are doing experiments to find out, like we mentioned, the quantum computer. If the quantum computer works, that implies parallel universe. Mm-hmm. And the question is, what do we mean by a parallel universe? It would be a different dimension. And this may sound strange, but they're trying to measure the distance between our universe and that universe. Uh-huh. And to get into that, we actually have to talk a great deal of topology. As to the way you do this in a 4, 5, or 20-dimensional space. And as you can tell, I don't think I'm prepared to talk about the multiple dimensions.
I was going to say, it's sailing over my head.
Yeah, but there is this question of the gravitational energy. Does it actually seep into these other dimensions? That is a legitimate question.
Yes, I've heard it said, Doctor, that is, if we're going to discover another dimension, that's how we're going to do it, by gravity.
Right, and the explanation, of the four fundamental forces, of the strong force, the weak force, and the gravitational force in there, people have said, why is the gravitational force so weak? It's so much weaker than the rest.
Mm-hmm.
And one explanation is because it goes through all these other dimensions. And the strong and weak force stay only in the three dimensions that we have.
Okay, caller, I think that's the best we can do.
Thanks.
Thank you very much for the call, and take care. Let's see. How about Jess on Skype?
Art Bell, welcome back.
Thank you.
Fantastic to have you back.
It's good to be here, as opposed to the alternative. Anyway, but do you have a question?
I do, sir.
Okay.
So I live in Iowa.
Okay.
And approximately around May or June, early part of June, I heard what was a loud bang, or it sounded like a car crash.
Mm-hmm.
I was sitting with 3 or 4 other gentlemen that evening, and we heard the bang, and nobody could really explain it. Now I'm kind of Google searching that there was an actual earthquake at New Madrid that night. Can Mr. Dvorak explain? We're 4.5 hours away from there.
Dr. Dvorak.
I'm sorry, Dr. Dvorak.
Oh, no, that's fine.
No,
John is okay.
It's a good question, Doctor. These big bangs, we're getting reports of these all over the place ahead of earthquakes. What in the world?
I don't have an answer. I would need more information as to exactly the timing and so forth. But as I mentioned, earthquake sounds are real, but we don't understand the physics of them.
Caller?
Well, thank you very much for the information.
Right. Thank you for the call. Yeah, these really are strange. These sudden bangs are just plain weird.
When Lewis and Clark, in their journals, when they went across the Great Plains,
yes,
Lewis writes about bangs, and people have scratched their heads. What is he hearing out there? The weather is clear.
Yeah.
And of course, when he talked to the people who were living out there, they said yes, these happen. And we're not sure what that is.
All right, being not sure is okay. Dustin on the phone. No, I'm sorry, Pottstown on the phone. You're on the air.
Yes, my name's Mike. I'm actually calling from Hagerstown, Maryland.
Okay.
Good evening, Art, and good evening, Dr. Dvorak. My question is, are you familiar with Charles Hapgood's theory of the Earth's crustal displacement? And it's the slippage of the entire crust of the Earth on the lithosphere as one solid motion. It's believed that the theory says that the Earth could have actually slipped as much as 40 degrees, where the core, the mantle, and stays in place and maintains its axis. But this does not conflict with the idea of plate tectonics, because plate tectonics, of course, plates ride on the lithosphere. And I think the theory originally started. It was a Russian study back in the 40s and 50s, and Charles Hapgood caught onto it, and he presented it to Albert Einstein. Einstein gave it some credibility. He didn't really acknowledge it as something that he was going to sign on to, but he didn't discount it completely. And my interest in this is the idea that recently there's been borehole drilling in Antarctica, and some of the specimens that have come up have shown tropical plants that were frozen nearly instantly. And so if this crustal slippage did actually happen, it could have brought Atlantis from near the equator down to where Antarctica is today. And then that would tie in with some of the ideas of why Hitler and Nazi Germany were so interested in Antarctica.
Wow. Anything to that theory, Doctor?
Well, it's very interesting, without a doubt, but I have to plead I'm ignorant about it.
Okay. It is true that they found tropical plants, of course, for example, at the North Pole, I think.
Yes.
In all
Antarctica and so forth.
Absolutely.
Right. And that's because of the drift of the tectonic plates. These things go back to very early parts of Earth history.
I know what I want to ask you about. With regard to earthquakes, I remember a really deep earthquake. It was like 400 miles down in the earth that occurred, and it was felt all over the East Coast. I mean, all over the place. It was just amazing. How can you have earthquakes 400 miles down?
Well, in the areas where the crust is going down into the earth, like in Japan,
yes,
or South America,
yes,
those earthquakes can originate down that deep, and that's because it's a cold part of the crust is going down. Huh. But exactly what the mechanism isn't clear. If it's a sliding of rocks, which is what happens near the surface,
yes,
or people have also suggested it's a phase change in the minerals.
Huh. They said it was like it rang
earthquakes that deep.
Yeah, it rang the earth like a bell, they said.
Yeah, a large earthquake will go around the earth and it rings like a bell. You're right.
Huh. Dustin on Skype, you're on the air. Hi.
Art, good evening. Welcome back.
Thank you.
Dr. Dvorak, fascinating topic you've been discussing. I do have a question regarding what we call the expanding universe.
Okay, you're kind of coming and going on your connection here. The expanding universe. Go ahead.
Yes, sir.
Yes.
Is there a physical boundary at the edge of the expansion? And if so, what might that be? And further, if so, what might lie beyond that? And God bless you. I'll take my answer on the air.
Thank you.
Okay.
All of us wonder.
Well, there is an edge to the universe. The easiest way to think of it is that it's an edge in time. The universe is only so old, and light can only travel so far in that time frame. There is a physical edge to it. There's a wall of radiation, and as I mentioned earlier, it's known as the cosmic microwave background radiation, and we've known about this since 1965. That's as far as radiation is able to go, and that is what you and I say is the universe. And the question is, for many reasons, some observations for inflation theory, there must be mass and energy beyond that. And exactly what it is, how similar or different it is from us, that's what people are trying to figure out. But that gets us into the question of the multiverse.
Right.
And there's certainly, in terms of thinking of geometry and so forth, yes, there's mass and energy that exists beyond. And as I mentioned earlier, the multiverse is mostly a froth of energy, probably very dense. And our universe that we see out there is this cold, low density thing that has space and time to it. And that's not what most of the multiverse is like. But there is an edge to the universe out there. When I go to the telescope, there's a limit to how far I can see.
What is that limit now?
Well, that limit is on the cosmic microwave background. What we see of it is at 13.7 billion light years. But the part we see, the light left a long time ago, right?
Mm-hmm.
And it continued to expand.
Yes.
And so what we're seeing now is probably out about 46 billion light years.
Wow.
Another way to think about it,
46.
If you're standing on land and you look out to the ocean, and there's a ship sailing away, and this ocean is sort of expanding, and the ship is riding the ocean. Mm-hmm. Eventually, it's going to go beyond what you can see.
Right.
And that's sort of what what people are trying to explain is going on here. The universe, as we know as astronomers, is that part that is confined with the electromagnetic radiation, the light.
Yes.
But there's mass and energy outside of it.
Did I hear you say...
The thing is finding experimental proof for it.
Yeah.
And that's what people are working extremely hard on, trying to find experimental proof for it.
Right. What did you say about 46 billion years? That one stumped me.
Oh, okay. So this wall that we see,
right,
at 13.7 billion years,
right,
because it's expanding, what we see is in the past.
I've got that, right.
And so what we see was 13.7 billion years ago.
Right.
But that has moved away from us.
Right.
And you just do on the calculations, that horizon now is now 46 billion light years away. I'm trying to not say now, because as we know from general relativity, there is no actual now in the universe.
Huh. Okay.
Because remember, all the clocks are going at different rates.
Right. I'm just not getting it. 46. I understand 13.7. You get a big bang.
There's an atom that's sitting out there at 13.7 billion years.
That I get.
Which we got radiation from, which I'm receiving at the telescope tonight.
Got it.
That atom, in those 13.7 billion years, has moved away. And it is now 46 billion light years away from me.
See, what I thought is that atom had moved away, yes, and was now 13.7.
No, that atom is 13.7 billion years ago for the light that I'm receiving tonight. But where is that atom now? Because, see, it took time for that light to get to me.
Okay.
And as that light's traveling to me, the whole universe is expanding, and so that atom has moved out another 30-some billion light years.
Okay. I guess. Okay, I'm going to have to meditate on that. I just don't grasp it. Sedalia, Missouri. Hello.
Hi, Art. I was wondering, what happened to George Norrie?
I have no idea. Thank you. North Hollywood, you're on the air. It says North Hollywood. Hello? Going once, going twice. Gone to Portland, Oregon. You're on the air. Hi.
Oh, well, welcome back, Art.
Thank you. Not a lot of time, so you're going to have to get it out quickly.
Okay. I was just curious what your guest's theory is on why atoms, to begin with, organize in such a manner that causes this world that we live in. I mean, it's like such a, it's just so complex and
perfect.
Such a, right down to the earthquakes and.
Well, that's a very good question. Philosophers have tried to solve it, and I don't think anybody's come up with a very good explanation as to exactly why. For me, having a passion in mathematics, I say it's in the mathematics. Very few people will accept that.
I know. And some will get downright angry about it, actually.
But to me, it's all math.
Doctor, our show is ending. It's been such a pleasure to have you here.
Well, I've enjoyed this greatly.
Well, thank you. Is there a website, or can people look you up and find out more?
Not yet. I'll have a website come up in about a month, because I just completed 2 books. And it'll describe that. One is about earthquakes. The other is about volcanoes.
What is the name of your next book?
My next book is called The Last Volcano. It's about the man who started the study of volcanoes.
That sounds ominous. The last.
That will come out in a month, and the one that's been out is Earthquake Storms, and it talks about the future destruction of California.
Cheery. All right. Doctor, thank you so much. We'll do it again, my friend.
I'm looking forward to it.
Good night. And from the high desert to the nation and the world, thank you for being here. Oh, don't forget, folks, open lines tomorrow night. We're going to do something special, that's for sure. So be here or be whatever you don't want to be. Good night.